Good day. Today we will be discussing about the conservation of energy. Okay, and we will apply this one on problems involving force, velocity, or conservation of energy from kinetic energy to potential energy. Okay, so but first, before we proceed with deriving the equation, we will first discuss what are conservative forces and what are some types of energy. Okay, so first we define a conservative force if the force is independent of the path. No, if the work of a force is independent of the path and it depends only on the force's initial and final position. So, say buot pasabotan niya. Okay, so ang work ko no done by a conservative force is not dependent on the path, meaning dili siya dependent on asa sa moagi, no? But rather dependent lang siya sa initial and final position. So let's have an example. Example is weight. No? Weight is a conservative force. Why? Because whether you measure the force ani nga location, compare nimo sa with the other location, as long as the same lang niya ang height, the same lang ang gyapon ang iya ang potential energy. Okay? And another example is the work done by a spring or the force developed by a spring. So the work done by a spring depends only on the spring's elongation or compression. No, magdepend ra ang iyang work based sa iya ang length wherein na elongate siya or na compress. In contrast, the non-conservative force, example na ini is friction. Okay? The force of friction exerted on a sliding object by a fixed surface depends on the path. No? So it depends on path, no? If your path wherein ahan mo gipatong ang imong ang object, example and smooth surface, o i-compare nimo sa rough surface, so mas dako og work done dito sa rough surface. Okay? Or mas dako kag work na kinahanglan i-exert. So meaning ana, it is dependent on the path asa siya moagi. So dili siya mag-depend sa imong ang final and initial position. Let's define energy. Now, in the elementary definition of energy, it is the capacity for doing work. Okay, so kinetic energy is equal to the work that must be done on the particle to bring it from a state of rest to a speed v. Kaya ang imo ang energy mo ni ang gamito nimo in order to do work. Okay, so you need to be able to calculate how much is the energy that must be supplied in order to mabuhat nimo ni execute nimo ni nga siya nga trabaho. Okay, so there are two types of mechanical energy. First is you have the gravitational potential energy. Okay, so ang gravitational potential energy, it is dependent on the height or the elevation of the object with respect to the datum. Okay, say for example, you have this one in figure 14-17. If this is your datum, okay, So if ang imo ang object is above the datum at a distance y, ang imo ang potential energy would be weight times the height. That is your potential energy. How about kung nasa sa ubo sa datum? So ang iyang potential energy is negative, no? Meaning on negative, you need to exert this amount of energy in order to bring this object into this position, the datum nimo. Okay, so I repeat, the potential energy, gravitational potential energy is denoted by V sub g, which is just equal to weight times the height. Another potential energy is, so you have the elastic potential energy, where an elastic spring is elongated or compressed a distance s from its unstretched position. Okay, this is denoted by the letter V sub E, which is just equal to positive 1 half k s squared. So, whether gi-elongate nimo or gi-compress nimo ang spring, mo ni ang iyang potential energy. Always positive. Okay, so do you have the potential function? Now, the potential function is just the summation of all the potential energies. Okay, you have the gravitational potential and you add the elastic potential energy. Now, the work done by a conservative force in moving the particle from one point to another is measured by the difference between this potential function. Okay, so this is the work done. So if the object is being moved from point 1 to point 2, so the work done is just the difference between this potential function v1 minus v2. Okay, okay, so after defining the types of energy, I will now proceed with the derivation of the conservation of energy. Okay, so based from the principle of work and energy, it is stated that T1, or the initial kinetic energy, plus the work is just equal to the final kinetic energy. But we were going to account the work done by conservative force and the work done by the non-conservative force. So recall that the summation of the work done by the conservative force is just V1 minus V2. Therefore, i-plug in nato ni siya, the work done by the conservative force plus the work done by the non-conservative force, and plug into the principle of work and energy, we'll get this equation. T1 plus B1 plus the summation of the non-conservative forces, the work done by non-conservative forces, is this equal to T2 plus V2. Now, if in case that only conservative forces are acting on the particle, so mazero na siya, therefore may mga rin T1 plus B1 is just equal to T2 plus V2. So this is now the conservation of mechanical energy, or just the conservation of energy. So what is this equation tells us is that the kinetic plus the potential energy at point 1 is just equal to the kinetic plus the potential energy at point 2. Okay, so if there are more than one particle that is involved, you just get the summation of these particles kinetic and potential energy again at point 1. So this is just equal to the summation of the kinetic and potential energy at point 2. Okay, so let's have an example. Let's take this example wherein you have a smooth 2 kilogram collar is as shown in the figure fits loosely on the vertical shaft. If the spring is unstretched when the collar is in position A, so at position A it is horizontal, so this is the unstretched position. Determine the speed at which the collar is moving when y is equals to 1 meter. So kung munaog ang imong object og 1 meter, what is the velocity? If it is released from rest at A, and B, it is released at A with an upward velocity 2 meters per second. Okay. Let's have this example, and you have a smooth 2 kilogram collar that fits loosely on a vertical shaft. If the spring is unstretched when the collar is in position A, so in this horizontal position, determine the speed at which the collar is moving when y is 1 meter. Now there are two scenarios. Here, first is the collar is released at A with 0 velocity, and second, when it is released with an upward velocity of 2 meters per second. Okay, so let's answer the first scenario by applying the conservation of energy. So T1 plus V1 is equal to T2 plus V2. Okay, first is that we need to establish our datum. Okay, so for this case, let's have our datum at point C. Okay, so this is point 1 and this is point 2. So what are the kinetic energy at point 1? Is there a kinetic energy? No, since ganyan rest, so it will be just 0. And then at V1, the potential energy. What are the potential energy? Diba? We have gravitational potential and elastic potential. Now, for point 1, there is no elastic potential energy. Why? Because the spring is okay. So since our collar is higher than our datum, so we have the gravitational potential energy. Therefore, we have mg times y, right? We have 2 times 9.81 times 1 meter is just equal to T2, which is what we are looking for, the velocity or the speed rather. Okay, so 1/2 m v squared plus the elastic and gravitational potential at point 2, right? But since ang gravitational potential at point 2 is naman there is datum, there is no height difference, so 0 na ang gravitational potential. What we are pangitaan na nato is ang elastic potential. Okay, so ang elastic potential is, what is the VE2 is just 1/2 Ks squared, right? So we have the K, pakitaan na nato ang pila ang stretch ani, pila ang strength ani. So we need to find pila ang length ani, right? para makuha nato ang S. Okay, so ang L2, okay, L2 is just L2 squared is just y squared plus 0.75 squared. By the way, ito nang diri na ito na solvon. Okay? Therefore, ang kaning y is just 1 raman eh. So 1 squared. Therefore, L2 would be ila ang L2? L2 would be 1.25 meter. Okay? 125. Okay. Now, ang original length, ang S2 nimo is just L2 minus LO, or original length is 0.75. Therefore, 1.25 minus 0.75 is 0.5 meters. So, may mo na lining 2 times 9.81 kani cancel nun v squared plus 1 half k. What is k? K is 3. 3.5 squared. Okay, muning solvon, V would be, or rather VC would be 4.39 meter per second going downward, right? Okay. Now let's proceed with the second scenario. Okay. The second scenario is that you release the collar with an upward velocity of 2 meters per second. So now the 2 meters per second upward. Okay, so almost the same running. Wala kayo ni maotro ani. Wala kayo maotro ani. Ang length sa imo ang S2 will still be 0.5 y kay 1 meter ang mangyapon. 1 meter may outro. So ang maotro lang ana is that T1 plus B1 T2 plus B2. In the first case 0 ni, but in the second mahimo na ning you have 1 half m 2 squared. Ano na siya? 1 half m 2 squared plus this one 2 times 9.81 is equal to 1 half 2v squared plus 1 half k s squared. Therefore, v would be 4.82 meter per second going downward. Okay. So, actually, whether upward or downward, the same ra ang imo ang velocity nga mukha nga naman kay gi-square man nimo. No, it would not matter ang direction diri sa imong kinetic kani nga case, no? Kay gi-square man na siya. Okay, so there are many examples in the book. Just practice solving.